Okay, we are taking the derivative and demonstrating the quotient rule. That's what we're focusing on here. We have d over dt, and this tells us, hey look, we need to take the derivative of this. And I'm claiming that that derivative is equal to all this stuff here. So what I suggest you to do is grab a pencil or a pen, preferably a pen, some paper, and start trying to work this out. And then use this video as a crutch to go back on. So what I do here is I get this out of radical form, put it in exponential form, and then we're going to take the derivative. So the quotient rule goes like this. We're going to take the derivative of the numerator, and the derivative of 5t squared is 10t. Rewrite the denominator minus the numerator times, and this is the derivative of the denominator. All this good stuff here. So we take the 1/2, you bring it out front, rewrite everything in parentheses, subtract 1 from the exponent, so 1 minus 1/2, or I should say 1/2 minus 1 gives us a negative 1/2. And then we do the chain rule part. We take the derivative of what's inside parentheses and chain it out. So the derivative of t squared is 2t. The derivative of 2t is just 2. And of course the derivative of 1 is 0. And then it's all over the denominator squared. Now it's time to simplify. And of course the best way to do this is to factor. But let's just look at something easy here first. Okay, so 1/2 times 2 is 1. So that's the reason I've just got t squared plus 2t minus 1 in the denominator. Now what I'm going to do is I'm going to come up here and let's see, what can we factor out? We have a t, we have a t squared, so we can factor a t out, and of course we always pull the one that's the smallest exponent out. This is to the first power, and this is to the second power. So we want to pull the t out so that's the first power. So there it is. Now it looks like I've got a 5 here. I factored a 5 out. We've got 10 as the coefficient, 5 over here is the coefficient, so we can factor a 5 out. And of course that's going to be left with a 2 here because 5 times 2 is 10, right? And t times whatever this stuff is here, you're just going to be left with t. Now what else am I going to factor out? I'm going to factor the t squared plus 2t minus 1 because this occurs also over here, except we have a power of 1/2 and a power of a negative 1/2. So you remember, you always pull the one out that has the smallest exponent. So we're going to pull this negative 1/2 out. Now if I pull the negative 1/2 out, we're just going to be left with t squared plus 2t minus 1 to the first power here. Right? Think about this. A negative 1/2 plus 1, right, that's the 1 power, gives us 1/2. And then let's see what's going on over here. Okay, so this 1/2 right here, I multiplied it across. 1/2 times 2t just gives us t, and 1/2 times 2 just gives us 1. So that's what happened to the half. Yeah, that's right. We had 2 t's here, but we factored 1 out, so we're only left with 1 t. Alright, so that should take care of that. Now I'm going to take this 2 and distribute it across, distribute the minus across, collect up some like terms. And then I take because this is a negative 1/2 here, let's write this with positive exponents. That means this is going to go down into the denominator. Right now it's a positive 1/2. And it's time, we need to collect up some like terms here. We got 2t squared minus t. Alright, so that's just going to give us a t squared, 4t, da 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 da. Alright, well after simplifying this down, this is what we're left with, and 1/2 plus 1 is 3/2.